Earthquakes is one of the largest natural hazards in the world. It has caused significant damage in roads, infrastructures, pipelines, homes, natural resources, and even cost many human lives. What made it more threatening is that the fact that its occurrences is unpredictable and it can happen anytime. Earthquakes, by definition, is the shaking of the earth. It is caused by a passage of seismic waves through the rocks. Seismic waves are produced when some form of energy is released to the Earth's crust. The size of an earthquake can be described by three components: earthquake intensity, earthquake magnitude, and earthquake energy. Earthquakes can happen at any location in the world. Depending on the region, the Earth's crust have a different soil properties that make some have a much higher probability of earthquakes than another. There are three large zones in the world that are extremely seismic. First, the Circum-Pacific Seismic Belt, also known as the Ring of Fire. This region is known to be the largest, causing 81% of the earthquakes in the world. Then we have the Alpine Earthquake Belt. This one's located through the Mediterranean to the Atlantic. And finally, we have a region that follows the submerged mid-Atlantic ridge. That's why in Canada, the most active seismic regions are found in the eastern and western areas. There are many hazards associated with earthquakes, and soil liquefaction is one of them. Seismic soil liquefaction is the sudden loss in stiffness and strength of soil under a cause of cycling loading. It is only restricted to certain geologic and hydraulic environments. Sands and silt with high groundwater levels are the regions most prone to these situations. Sands has large particles with a lot of air pores in between. When the water table is high, the presence of water rises up to fill in those pores. During an earthquake, the soil contracts, but the presence of water prevents such contraction, causing a rise in pore pressure and resulting a drop in effective stress. If the effective stress drops to zero, the stiffness and strength of the soil also drops down to zero, causing the soil to behave like a heavy fluid. I'll be showing a demonstration of how liquefaction works. First, I will add the water. This will represent the ground water table. We'll assume a high water level for this experiment. Then we'll add the soil sample. In this case, we have sand. We'll just add sand just until the surface is dry. Then we can add our superstructure. I have here a weighted building and a post. Now we can shake the container to portray the sucking loadings effects of an earthquake. As seen, the soil behaves as a heavy liquid, causing the weight to sink. Some real-life event that happened is at the Niigata, Japan in 1964, as well as at the Port Royal that happened back in 1692. It is almost impossible to predict earthquakes at this time. However, geotechnical engineers follows modern manuals, codes and standards to ensure the safety of the public.